Hi Math 34 students. This is Module 2C, Example 1 on page 46. And remember to read through your example or your Module 2C vocabulary on page 45 before starting these questions. So this STEM plot gives us the travel times to work in minutes from 20 random workers in New York State. And our first task is to find the median and draw a line or an arrow in the STEM plot to indicate the location of this median. So there's 20 random workers, so we know that the median will be in the middle between the 10th and the 11th worker times. Remember, there's an even number, so we're going to expect two values to be in the middle, so we're going to have to average those to find the median. And if we count out, we'll see it's right here between 20 and 25. And remember, this is 20 because the stem is 2 and the 0 is in the leaf spot. And so we want to, let's go ahead and try to circle this. See if I can circle it. So you can still see it. There we go. And then I'm going to go ahead and label this as our median, and we know we can use the letter M for median, is going to be between 20 and 25. So if you take that average, you'll see that's 22.5. And we want to say minutes. So we can copy this and paste it down here. And we circled it. We could draw an arrow in here too. How many numbers fall below the median? So the median isn't both of these. It's actually right in the middle. So let me try to draw. Let me try to swing the arrow. So the median isn't 20 or 25. It's this 22.5 in the middle. So below that are 10 numbers if you count them up, and above that are 10 other numbers because the 22.5 doesn't count as one of the numbers, it's just in the middle. So we can put a note here, there are 10 numbers above and below the median. Now part C is asking us to find the number 25% of the way through the data set. In other words, this is going to be the middle of the first half of the median, and this is called the first quartile, and it's written with a Q1. So if we count through the middle of these first 10 numbers, we're going to see that's going to be between the 5th and the 6th numbers right here. So let's go ahead and put a circle in here between the 5th and the 6th numbers. We can make an arrow. Oh, we gotta reverse our arrow the other way. Okay, so this is what we call quartile 1. So we label it as Q, usually with a little 1. I'm just gonna say Q1. And that's going to be the average of 15 and 15, so that'll be 15 minutes. And we can put a note down here, Q1 equals 15 minutes. The next number is the number 75% of the way through the data set, which we call quartile 3, or we use Q3. So we're going to do the same process, and we'll start at 25 and count through until we find the 15th and the 16th number. So if we go 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, there's 20. No, so it would be right here between the 0 and the 5. So we'll circle those. Yeah, that's between the 15th and the 16th numbers. And we can draw an arrow. And this is our quartile 3. And it's going to be the average between 40 and 45, so it's going to be 42.5 minutes. And we can make a note of this down here. Notice it's 3/4 or 75% of the way through the data set. So that word third quartile means 3 out of 4 of the way through, or 75%. We can make a note here, Q3 equals 42.5 minutes. So now we can make what's called the 5-number summary, which is a list of these 5 numbers that describe the distribution. So we first put the minimum, then the first quartile, then the median in the middle, which is actually just the second quartile, the third quartile, and the maximum. And this 5-number summary gives us information about the data. It lets us see the distribution. So our 5-number summary here for New York is going to start with our minimum of 5 minutes, quartile 1 of 15 minutes, the median of 22.5 minutes, quartile 3, which is 42.5 minutes, and then the maximum here is 85 minutes. And what this does is we can see about how far the distance or the time is in between the different numbers. So from the minimum to quartile 1, that's 10 minutes apart. From the quartile 1 to the median, we can see that's only 7.5 minutes apart. So we can see more commute times are compressed in this first area between quartile 1 and the median because it's got a smaller range of data values. If you look between quartile 3 and the maximum from 42.5 to 85, you can see the data must be more spread out here because this is a wider range. Let's go ahead and look at example 2 on page 47. This is about reading box plots. So these examples in the graph here are of box plots. And a box plot is a visual graph of this 5-number summary. And the box plot is useful if you're comparing 2 data sets side by side. So you can see here on our graph, the first box plot is for North Carolina and the second box plot is for New York. And the y-axis is measuring travel time to work in minutes. So each indication on the box is one of those numbers from our 5-number summary. So in New York, you see the bottom here is the minimum, which is 5. And if you look over, you can see, oh yeah, right between 0 and 10, there's our minimum of 5. The first quartile is this line here at the start of the box at 15, and you can see it goes right through here. The median 22.5 is right up here. That's the middle of the box. And then the third quartile at 42.5 is up here. So remember we talked about how it was more compressed from the first quartile to the median and more stretched out from the median to the third quartile. And then our maximum of 85 is really far away, so we can see that stretch here on the box plot. Sometimes these are called box and whiskers plots because these longer lines at the side look a little bit like whiskers on a cat or something. So if you hear the phrase box and whisker plot, you'll know they're talking about the box plot. So do these numbers that we see in the New York agree with what we just calculated? Yes, they do. So we can check our work. So we want to label North Carolina state in the same way that New York is labeled. So we'll go ahead and give it a go. So the minimum here looks like it's also 5. I'm going to label over here. Quartile 1 looks like 10. The median looks like it's 20. And then it looks like quartile 3 is 30. And then the maximum up here looks to be right at 60 to me. You might be able to see a little bit better on your paper. Okay, so now we can compare the medians side by side. Question B asks which state has the higher median. So we see New York at 22.5 is higher than North Carolina at 20. Question C asks which state has the lower first quartile. So if we compare our first quartile, New York is 15, North Carolina is 10 minutes. So North Carolina has the lower first quartile. D is asking us to calculate what's called the interquartile range. So that's the distance between the first and the third quartiles. So for North Carolina, our IQR is going to be the third quartile, which is 30, minus the first quartile of 10. And that's going to be 20. And remember, these are minutes, 20 minutes. For New York, and we use IQR to shorthand represent the interquartile range. The distance between quartile 3, 42.5, and quartile 1 is 15. So 42.5 minus 15, and let's see if we subtract this on our calculator. I think this is 27.5. So which state has this larger of these interquartile ranges? Well, we see in New York 27.5 minutes is greater. And if you look at the graph, you can see that box for the interquartile is wider than the box for North Carolina. Question F is asking which state has the greater spread from minimum to maximum. So if we look up here, we can see really clearly New York goes all the way from 5 to 85 from minimum to maximum, and so it has the larger spread. If you wanted to calculate the spread, you could actually say spread equals 85 minus 5 equals 80 minutes. So the spread is just the distance from maximum to minimum. Sometimes in sports, you hear people talking about the point spread when they're discussing baseball, football, basketball games. So the point spread is how far from the maximum to the minimum in the scores in the game.